We're going to do this example now, 9x plus 2y equals 5. So it's really just like what I said before, okay? Namely, we set the other variable equal to 0. So in this case, we're going to set y to, we're looking for the x-intercept first. So for that, we're going to set y to be 0. Right? The other variable, y in this case. So we replace y by 0, and the 2 times y, well, that's gone, right? All we're left with is 9 times x equals 5. So that's what we have here. And then, of course, what do we do next? Well, we just divide because we get x. So we get x is 5 over 9. So 5 over 9 is the x-intercept. Let me just circle that. So if I ask for the x-intercept, you don't want to give a point. I mean, I did write here that this point is on the graph, but 5 over 9 is the answer. I mean, if you did happen to write 5 over 9 comma 0, since I made the mistake of putting it here, I'm not going to take points off for that. So I care more about that you can get x, and you know that you set y equal to 0. All right. Okay. Now that's for the x-intercept. So for the y-intercept, right, what do we get here? Well, it's the same idea. We just basically, the variables switch roles, so to say, if that makes sense. So we're going to set x to be 0, and we solve for y, okay? And so in that case, we're going to have 9 times 0 plus 2y is 5. I don't know why that's an x over there, but that should be a y. So I fix that. So what we have here is, 9 times 0 plus 2y is 5. And then you're just getting y, okay? So we divide by 2. So yes, that does tell us that this is also on the graph, because when x is 0, we get y has to be 5 over 2, meaning this is a solution to this equation. But the actual answer is, here, let me circle the answer. The actual answer, of course, is this. You're looking for a number, not a point. Okay. Okay, so we get that, so that's good. So we have that. Are there any questions on this? Okay, let's keep going then. And I just also graphed it as well. I mean, later on, we'll actually see that this is, I mean, here I showed you already, but even without the graph, but beforehand, we'll see that this is a line. And by getting 2 points like this, we'll be able to graph it. But as you can see, we have the graph here. Here's the y-intercept, and here's our x-intercept. Okay, good. I wrote these as decimals. Well, actually, Desmos did, but that's okay. Same thing. All right. So this was something we did last time as well. Namely, last time we saw a circle, right? And this is the equation of a circle, the standard form, actually, that is. I mean, another form you can get by actually foiling these two out, but let's just stick with this. If you get to the more general form, then you really have to understand the method of completing the squares. For time consideration, I'm not going to cover that, so let's just stick with this. But anyway, the standard form of an equation of a circle, it looks like this. HK is the center of the circle, okay? The radius is R. Remember, for a circle, okay, right? A circle with center HK of radius R, it's all points in the Cartesian plane that are R units from the center. are units from the center. So in other words, if you take the center and any point on that circle and calculate the distance or the length of the line segment connecting them, you should get R. All right. Okay, so let's do an example, then we'll do some others where I will let you try them. So for instance, if we were to graph this circle here, right? I put the standard form below it, but hopefully you can see by comparing, right, that we could take h to be 3, x minus h, x minus 3. So h is 3, y minus 5, y minus k. So k is 5. So in other words, the center, so hk would be 3, 5, which is the center. R squared is 5. So R would be radical 5. In other words, we have this. And really, this is the hard part. Once you get the center and the radius, really you're home free. You know, because that's really what you need to sketch a circle, the center and the radius. Although, as we'll see later, you could actually get an equation of the circle if you have the center and another point on the circle. I mean, as far as I know, you have to have the center at least. So, and if we were to graph it in the xy plane, this is what the circle would look like. Except though it's at 3, 2, not 3, 5, so that's a mistake there. I probably originally had it at 3, 2, but it should have been at 3, 5, so I'll have to fix that. When I post the notes, I'll fix that though. So, all right. Okay, I mean, except for the graph though, here, are there any questions about this? I think the mistake I made was well, it's in the graph, not here. Because this should be at 3, 5, not 3, 2. So okay. I think originally I had this as 2 and I changed it to 5 for today. So all right. I'll fix that later when I post these. All right, so here's another example. So let's see. Let's go through the together. I mean, I wrote have them try, but why don't we go through some of these together? For the first one, we want a circle, okay, whose center is 4, 5, and the radius is 9. So the center is 4, 5, and the radius, we want it to be 9. Actually, not 9, it should be 3. Let me just fix that quickly. I meant to write 3. It's easy to fix. Actually, wait a minute. Let me just quickly fix that. There we go. Okay. So if we were to do this, okay, right? So again, it's really just looking at the standard form of an equation of a circle, right? The standard form is this, where HK is the center, R is the radius. Okay. Okay, so that should be a 3. Just fix that. Good. Okay. So anyway, we have, right, as you can see, we can so from here, we have H is going to be 4, K is going to be 5. Remember, if you have 2 points, okay, equal to each other, that means their X coordinates are the same and their Y coordinates have to be the same as well. So h is going to be 4, k is going to be 5. So what we do is we just plug it in here, so to say, and we get this. Now the radius is 3, that's what r is. So we take r to be 3 and we get this. If you wrote it as 9 instead of 3 squared, that's fine. So that's our first example. Before I get to the second, let me just stop the recording. But hopefully from here, you can get the idea at least that if you know the center and you know the radius, essentially you're just going to plug them into here. That's really all you have to do, right? So if you have the center in this case, which is 4, 5, right? And you want that to be the center, then your h is going to be 4, k is going to be 5. That's what I did here, right? This is the center. And the radius is r. And it's equal to the radius squared, so 3 squared, because the radius is 3. Well, here's another one. It's the same idea. I mean, yes, we have -2, -8. We have two minuses here, so to say. It's really the same idea, though. This is the standard form, right? HK is the center, so HK has to be this point. That's what we're doing. Okay. So H is going to be -2. K is going to be -8 then. Again, 2 points are equal. Their x coordinates. Yeah, let me actually draw it in. That might help. Their x coordinates are the same, and their y coordinates are the same. Okay? If 2 points are equal, that's what's going to happen. Okay? And so we take h to be -2, k to be -8, and that's what I'm plugging in here. That's what we're plugging in here. Okay, and the radius is 4, right? So r is 4, so we have 4 squared. It's not the best to write it as minus a negative. It's better to write minus a negative as addition, and that's what I did over here. That's all. I mean, I guess theoretically this is correct, but it's just better to write as addition instead of subtracting a negative, to write it as addition. So, but notice though, if you happen to have this addition here, for the center, you always want it to be minus though. So if I happen to give you this equation, the center would not be 2, 8. It would be -2, -8. You want to make sure you actually, when you read off it, you want to make sure you have minus a negative when you're reading off the center, if that makes sense. Yeah. X minus something. And if you have addition, you could think of that as minus the negative. Same thing over here. Okay. For the next one, this one's a little bit different. Okay. We want to get an equation of this circle. Okay, so what are we missing? Can someone tell me?
The radius.
The radius, correct. Right? We have the center, that's 1, 3. But we can easily get the radius, right? Because we know I give you another point on the circle, 5, 7. What do? We're going to use distance. So you know what? Take a minute right now to calculate the distance, everyone. Let me just pause the recording. I want everyone to